Hello everyone, here is Afra Sahab. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended. Paper code is 0625 with variant 43, held on May or June 2020 and time duration is 1 hour 15 minutes. Let's start from question number 1. Question number 1, Part A. Define acceleration. Acceleration is defined as the time rate of change of velocity of body, or it may be defined as the gradient of velocity. So I write here time rate of change of velocity of body. Part B. Figure 1.1 shows two speed time graph A and B and two distance time graphs C and D. So there are speed time graph and also the distance time graph. The speed time graph is A and B, while the distance time graphs are C and D. You can see from here. Describe the motion shown by graph A. Here you can see in the graph A that speed is decreasing with time. And when speed is decreasing with time, it means that there is a deceleration. And we know that the slope of speed time graph gives out the acceleration. That's why this graph gives us the deceleration. So we also talk about the gradient, and you can see here that the gradient remains constant. So this graph is basically the constant deceleration. I write here now moving towards the graph B. It's also a speed time graph, and you can see from this curve that the speed is increasing with time. When speed increases with time, we get the increasing acceleration. And when we talk about the gradient of this graph, you can see here that the gradient is also changing. First of all, I draw the gradient at the starting point. It will be just like this. But at the ending point, the gradient will be like this. So you can see from here that first of all gradient is this, then it increases in this way. So the gradient is increasing and this graph shows the increasing acceleration. So I write here increasing acceleration. Part 3, graph C. Here we have to describe about the graph C, and it's a distance time graph. You can see from here that it's a distance time graph, and the slope of distance time graph gives us speed, because speed is equal to distance over time. you can see from this curve that the speed is decreasing, and when we talk about its gradient, I draw the same tangent at the starting and ending point. At the starting point, it is just like this, and at ending point, the tangent will be in this direction. So you can see from here that the gradient is decreasing and speed is also decreasing. So it's the decreasing speed graph. Now graph D. You can see the graph D, it's a straight line, and it shows that the speed is constant because the distance time graph, its slope gives us the speed, and the distance is changing in equal amount with the increase in time. So it is a constant speed graph. Question number 2. A scientist fills a container with seawater. The container has a dimension of 30 cm cross 30 cm cross 40 cm. The density of seawater is 1020 kg per meter cube. Part A. Calculate the mass of the seawater in the container. Here we have to calculate the mass, and we know that density is represented by rho. It is equal to mass per unit volume. Here for calculation of mass, we multiply density and volume, and density is given in the question, which is 1020 kg per meter cube, and we have to calculate the volume. So here you can see that dimension is also given, and we have to calculate the volume from this dimension, and the standard unit of length is meter, and that's why the standard unit of volume is cubic meter. But here first of all we have to convert the centimeter into meter, and for that we do 30 divided by 100 multiply by 30 divided by 100 multiply by 40 divided by 100, and then volume comes to be meter cube. So the total volume comes to be 0.036 meter cube. I put the value of this volume and density into this formula so that I get 1020 multiplied by 0.036, and it comes to be 37 kilogram. So mass comes to be 37 kilogram. Part B. Here is a figure 2.1. Part B, figure 2.1 shows a submarine. The submarine is fully submerged in the sea. 1. The atmospheric pressure is 100 kilopascal, and the total pressure on the top surface of the submarine is 500 kilopascal. Calculate the depth of the top surface of the submarine below the surface of sea. Here we have to calculate the depth. We know two formulas for calculation of pressure. One is P is equal to force per unit area, and other is P is equal to rho GH. Here depth means that we have to calculate the height, and from this formula we can easily calculate height if pressure, density and value of G is known. We know that density is given 1020 and G's value is 10 meter per second square, and pressure is also we have to calculate. First of all, if I consider that it is the surface of sea and It's the submarine. And you can see here that atmospheric pressure is 100 kilopascal. Here pressure is 100 kilopascal and the total pressure on the top surface of the submarine is 500 kilopascal. So the total pressure from the surface is basically 500 kilopascal. Calculate the depth of top surface of the submarine below the surface of sea. So we have to calculate this pressure. This pressure comes to be 500 minus 100 and it comes to be 400 kilopascal. Because we know that total pressure is equal to the pressure due to air plus pressure due to liquid. So we can find out that pressure comes to be 400 kilopascal. Here we have to calculate height. Height comes to be P over rho g. Pressure is 400 and kilo means 1000 divided by density is 1020 multiplied by the value of g is 10. So after calculation the height comes to be 39 meter. So the depth will be equal to 39 meters. Second part. A hatch and operating door on the top surface of submarine has an area of 0.62 meters square. Here area is given. Calculate the downward force on the hatch due to the total pressure on the top surface of submarine. Here we have to calculate the total force that is due to the total pressure on the top surface of submarine. And you can see here that the total pressure on the top surface of submarine is given as 500 kilopascal. So we use this formula and we know that force is equal to pressure multiplied by area. I derive this formula for P is equal to F over A. So I put the values of pressure and area here. 500 multiplied by 1000 multiplied by area is given 0.62 and then the downward force comes to be 31. The force is measured in Newton. So the total force will be this. Question number 3. In a double-decker bus, there are two passenger compartments, one above the other. Part A. Figure 3.1 shows a double-decker bus on a tiled platform. The platform is used to test the stability of the bus. The angle the bus makes with the horizontal is gradually increased until the bus begins to topple to the left. Explain why the bus begins to topple. So first of all, you can see here in the figure 3.1 that it's the top compartment while it's the bottom compartment. And if I draw a balance here, so it's the balance according to the position of bus in this frame. If I also draw a line at its center, you can see here half of the weight will lie on the left hand side while the half of the weight will lie on the right hand side. It means that the weight on both sides are equal and force is also same, which means that the clockwise movement will be equal to the anti-clockwise movement. So it's the balance. Next is that we have to increase its angle. So I'm going to change its position. So here I have increased the angle theta. You can see that and if I draw a line at the middle, then on the left hand side and on the right hand side the weights are not equal. You can see from here that left hand side have more weight as compared to right hand side. So we can simply say that the anti-clockwise movement will be larger as compared to the clockwise movement, as left hand side has more weight, due to which this anti-clockwise movement will be larger as compared to the clockwise movement, and we can simply say that the bus starts to topple to left. So I write here anti-clockwise movement is greater than clockwise movement. That's why the bus began to topple to the left. Part B. There are 30 passengers in the upper compartment of the bus and 2 passengers in the bottom compartment of the bus. State how this affects the stability of bus and reason for that. First of all, we again go back to the diagram and see that if this upper compartment has 30 passengers while the lower has 2. So it must not be stable because both of the compartment the weight is not balanced, and it's more likely to fall over, because think about center of mass first. If I draw the center of mass, The center of mass of this would be at this point, its original center of mass. But when the top compartment has 30 passengers and bottom compartment has 2 passengers, then the center of mass position will be changes and it goes to at this point. Now, if I draw a baseline, and it's also a line, that is line of action, it's vertically downward. That passing through this center of mass. So, you can see from here that the place where the line of action does not meet with the baseline of bus. So, it's unstable and that's why it has less stability. So, I write here bus is more likely to fall because it is less stable and the line of action of center of mass may fall outside the base of bus. So, going towards the other part of this question, part C. A bus is traveling along a straight road. The bus and the driver have a combined mass of 16,000 kg when there are no passengers in it. The bus has 73 passengers. The average mass of each of the passengers is 65 kg. Part 1. Calculate the total mass of the bus. Here we have to calculate the total mass of bus as the bus contains driver and also passengers. So we have to add the mass of each of them. So, first of all in the question it is given that the bus and the driver has a combined mass of 16,000. It means that the bus and driver mass is 16,000 kg and for 73 passengers, each passenger has weight 65 kg. This one. So I multiply 73 with 65 and then add both of them to get the total mass. So 16,000 plus 73 multiplied by 65 and it comes to be 20700 kg and it may be approximately equal to 21,000. So I write here mass is equal to 21,000 kilogram. Part 2. The fully loaded bus accelerates uniformly from rest. So the bus is accelerating from rest. It means that its initial velocity is equal to 0 to a speed of 14 meter per second. It's the final speed of the bus. The time taken to reach a speed of 14 meter per second is 20 seconds. So time is given, that is 20 seconds. Calculate the resultant force on the bus during the acceleration. Here we have to calculate the resultant force. We know that F is equal to ma, that is from Newton's second law of motion. Here we don't know the value of acceleration. So first of all we have to calculate it. We know that acceleration is equal to change in velocity per time. So I write here final velocity minus initial velocity divided by time. We get 14 minus initial velocity is 0 because bus starts from rest and time is given as 20 seconds. So the acceleration comes to be 0.7 meter per second square. Now I am putting this value into this equation. Force comes to be F is equal to mass is given, we already calculate, it is 21,000 multiplied by acceleration is 0.7. So we get as 14,700 Newton. As force is measured in Newton, so it is 14,700 Newton. So I write here question number 4. Describe in terms of molecules what happens when a liquid evaporates. So first of all we have to know about the evaporation. So the escaping of the molecules from the surface of liquid is known as evaporation. If I consider that in this beaker there is a liquid and it's the surface of liquid, the molecules that have high energy will escape from the surface of liquid. Molecules of low energy remains on the surface and they do not escape because they don't have enough energy. As a result, the temperature of liquid decreases and as only less energy molecules left behind, so the average kinetic energy of the remaining molecules would be lower. So I am writing here molecules escape from surface of liquid more energetic molecules escape less energetic molecule left behind. So the temperature of liquid decrease because average kinetic energy of remaining molecules is lower. So you have to write all of these steps. Part B. You can see here there is a figure. Figure 4.1 shows wet cloths drying on a washing line in an outside area. State two changes in the weather that help the wet cloths to dry more quickly. So here we have to describe the two changes that we can done in the weather so that these cloths will dry very quickly. First of all, if the temperature is increased, then there will be more chance for cloths to dry quickly. So air temperature increased. Air temperature increase. Second one is that if there is more wind blowing at the surface, then the cloth will dry very quickly. Second one is more wind. And there is also one reason that the light from the sun directly falls on this cloth. Then there will be more possibility for cloth to dry quickly. So I write here cloud stops covering the sun so that more sunlight comes and fall on these cloths. Question number 5. Part A. Figure 5.1 shows a plastic cup. The cup contains sand, electric heater and a thermometer. You can see here that in the figure 5.1 there is a plastic cup and there is also a thermometer, electric heater and sand. The power of heater is 50 watt. The mass of the sand in the cup is 550 gram. The initial temperature of sand is 20 degrees C. The heater is switched on for 2 minutes. The temperature is recorded until the temperature stops increasing. The highest temperature recorded by the thermometer 33 degrees C. Part 1. Calculate the energy supplied by the heater. Here we have to calculate the energy supplied. So there is a lot of data. There are a lot of values in the question, but we know that energy is equal to P cross T. Here we just use the value of power and time. Power is given 50 watt and time is 2 minutes. We have to convert these minutes into seconds. So what will we do? We multiply it with 60. It's 2. 2.0 multiplied by 60 and it comes to be 120 seconds. So I'm going to put in value here. P is 50 watt multiplied by 120 seconds and energy comes to be 6000 joule. So I write here part 2. Calculate a value for the specific heat capacity. Here we have to calculate the specific heat capacity of the sand using your answer to part A1 and the data in the question. Here we have to calculate the specific heat capacity and we know that energy is equal to mass times specific heat capacity times the change in temperature. Here we have to calculate the change in temperature for our sand. That's why the initial temperature of sand is 20 degrees C while the final temperature is 33. So I'm separating C is equal to E over M delta T. So E we have already calculated 6000 divided by mass is given as 550 gram multiplied by change in temperature is 33 minus 20 degrees C. So after calculation we get C comes to be 0.845. Its unit is joule per. As the mass is given in gram, so joule per gram and degree C. We have to be very careful about its unit. So specific heat capacity comes to be 0.845 joule per gram degree C. Parts 3. Explain why the specific heat capacity of the sand may be different from the value calculated in A2. So, we have calculated the value of specific heat capacity that comes to be 0.845 and its value is different from the specific heat capacity of sand. Here we have to tell the reason for that. So, first of all, you see this figure, that this figure is not covered from the top. There is no lid above it. So it might be possible that the energy from inside may escape in the surrounding and the energy supplied by the heater may not be represent the energy received by the sand. As a result, the energy inside it decreases and from the relation E is equal to mc delta T. If the change in temperature is constant and mass is also constant, then decrease in energy cause decrease in specific heat capacity. So there must be the decrease in specific heat capacity. Other reason for that is, if I consider that the temperature of outside is 50 degrees C and inside is almost 20 to 30 degrees C. As outside has more temperature as compared to inside, the heat from outside may flow inside and there is more heat inside the plastic cup. So, some of the energy from the surrounding will be absorbed by the sand and there will be high temperature and high energy contained within the sand. So, due to this high energy, the specific heat capacity also increases. Here also delta T and M is constant and increase in energy causes the increase in specific heat capacity. So, it would be different from the value that is calculated in the part 2. So, I write here sum of the energy supplied by the heater goes to surroundings as a result the specific heat capacity will be lower. And the other reason for this is some energy may be absorbed from surrounding if they are at high temperature. It means that if the surrounding temperature is more as compared to cup, then the specific heat capacity will be higher. You may write any one of these reasons. So next part is B. On a sunny day, the temperature of the sand on a beach is much higher than the temperature of the sea. Explain why. So as we know that water takes much time to be heated as compared to sand, and the reason for that is the specific heat capacity for water is greater than the specific heat capacity for sand. This means that water requires more energy to be heated, and since on beach some rate of energy is supplied to sand and sea, that's why the temperature of sand on a beach is much higher than the temperature of the sea. So I write here specific heat capacity of water is much higher than that of sand. Some rate of energy is being supplied to sand and sea. Part C. Draw a label diagram to show the structure of thermocouple thermometer. Here we have to draw the structure. So first of all I used ruler. As the thermocouple thermometer contains voltmeter, cooled junction, hot junction, copper wire, and last one is iron wire. On the figure we have to mention all of these components. Here if I consider this point and meet this point with this, Similarly, I made this point with the other. And here we attached voltmeter. It is the lower line. And then we have to make hot junction at this side. You have to make it very carefully. It's a hard junction. It's voltmeter. And it is cold junction. At this point is copper wire. And at this point there is iron wire. So we have completed the diagram of thermocouple thermometer with proper labeling. Question number 6, part A. Figure 6.1 shows crest of a sound wave after reflection from a solid sphere. So you can see that these are the wave and these are reflected from the solid surface. On figure 6.1, draw three crests of the incident wave. Here we have to draw the incident wave. To draw the incident wave, we have to follow the following steps. First of all, we have to draw normal. At each crest. After drawing the normal, we have to identify the angle of reflection. And by law of reflection, we know that the angle of incidence must be equal to angle of reflection. By using this, we draw the rays at the same angle as that of angle of refraction. Then draw incident rays. So first of all, I am going to draw the normal. Here they are asked to draw three crests. So first of all, I draw the normal. This is second normal. And it's third normal. And we know that the angle between the reflected ray and normal ray is known as angle of refraction. In our case, the angle of refraction is this. We carefully have to identify this angle and draw the incident ray. It might be the incident angle. So I draw the incident ray here. All of these rays must be parallel and the distance between them must remain same. You should be careful about that. Now I have to draw these incident ray. Now I have to erase all of the normal ray. These are the incident ray. And make sure that the distance between these two crusts, I again redraw it. So you have to make sure the distance between those must be equal because it's the wavelength and it must be equal to that of the reflected ray. So moving towards the other part of this question. Part B. Tick 4 statements in the list below that are false. We have to tick the false statements for a sound wave that is audible to a healthy human ear. We have to tick the false statement for the sound waves that can be listened by the healthy human ear. First of all, sound wave is longitudinal. We know that the sound wave is basically longitudinal. It's a correct statement. So, in this case, we have to tick the false one. So, it's not correct. We don't tick it. Second one is the wave is transverse. We know that the sound wave are not transverse in nature. That's why it is the false statement. I am going to tick it. The frequency of the wave is 1 Hz. The human can hear the sound of frequency 1 Hz to 20 Hz to 20 kilohertz. So here they are talking about 1 Hz. It is not audible by the healthy human ear. That's why it is also false statement. And I am going to tick this one. The frequency of the wave is 1 kilohertz. So 1 kilohertz lies in this range and it is audible by the human. That's why it is a correct statement. I'm not going to tick this one. The frequency of the wave is 1 megahertz. This is very large frequency that is out of this frequency limit. So it is also false. The wave travel in the vacuum. Here we are considering the sound wave, and if we consider that sound wave travels in the vacuum, then we cannot hear them. So this is also a false statement and I am going to tick it. The wave could travel in the aluminium. If this happens that the sound wave travels in the aluminium, then we can hear it. So it is also a correct statement and I am not going to tick this one because we have to tick the false statements. Part C. State a typical value of the speed of sound in the water. Here we have to tell the speed of sound in water. We know that in the air, speed is equal to 340 meter per second. And they have asked about water, and in the water its value is 1500 meter per second. We have to memorize these values. Question number 7. Figure 7.1 shows red light traveling from air into prism made of diamond. So the prism is made of diamond. The path of the red light is incomplete. Part A. The refractive index of diamond is 2.42. Calculate the angle x. Here we have to calculate this angle x. In the diagram 7.1, you can see that this is the incident ray and it falls at the surface of prism at the angle 40. At that point, we have drawn the normal, which is represented by this line. And we know that the normal is perpendicular to surface. The angle between them is 90. Here we have to find out the angle x, which is the refracted angle, and we know that n is equal to sine of angle of incidence over sine of angle of refraction. Here we have to find out this r, and r is the angle of refraction. It is represented by x, so I write here sine of I over sine of x. We have to find out the value of x. The refractive index of diamond is given, which is 2.42. Here we have to find out the incidence angle. So we know that the incidence angle is formed between the incident ray and normal ray. So this angle 40 is not incidence angle. I draw it in the side. It is the incidence angle. And I write here I will be equal to 90 minus 40. I write here 90 degree because the surface is perpendicular to the normal ray. That's why the angle of incidence comes to be 50. So putting values in this equation, sine of x will be equal to sine of I over n, and sine of I will be equal to sine function of 50 degree divided by n is 2.42. We have to calculate x. That's why we have to take sine inverse of this value. And x comes to be 18.454. It is approximately equal to 18 degree. So the angle x will be 18 degree. Part B. Explain the term total internal reflection. Here we have to define what is total internal reflection. So let's suppose that I have two surfaces. One is denser medium. For the definition of total internal reflection, consider I have two medium. One is denser medium while other is less denser medium. Below here consider that it is the denser medium. And above this line is rare medium, which is less denser. So I draw a normal ray at its surface. It is normal ray. Consider that ray of light from denser medium. This is denser medium. And this is less denser medium. Or it is also be called rare medium. When a ray of light from denser medium falls on the surface, then what will happen? I am drawing it is the incident ray, and then it will refract it. It will go just like this. Now you can see that this is the angle of incidence I. Now I am going to increase the angle of incidence, then what will happen? This is another ray. I also draw another ray here. All of these are the incident ray. The angle of incidence for which the angle of refraction is equal to 90. You can see here it is the angle of refraction. If the angle of refraction become parallel to this surface, it means that it is totally refracted. I am drawing the refracted ray here. This is the refracted ray for this angle of incidence. When I goes to increase the angle of incidence, angle of refraction also increases. The angle of incidence for which the angle of refraction is equal to 90. This angle is known as critical angle and I represent it with C. It is the critical angle. Any ray that enters at the angle that is greater than critical angle, it will totally reflect it. So, I am also drawing another ray whose angle of incidence is greater than critical angle. I represent it with red. Then it will totally reflect it. Just like this. This phenomena is known as total internal reflection. So I write here, when light travels from optically denser medium to optically less denser medium, all light is reflected if the incidence angle is greater than critical angle. And know what is critical angle? I am writing here the angle of incidence for which a refracted angle becomes 90 degree. It's the definition of critical angle. moving towards the other part of this question, that is, the angle y is greater than the critical angle of diamond. So here y is the angle shown in the figure that is greater than the critical angle. It means that when the angle is greater than critical angle, there will be totally internal reflection. On figure 7.1, draw the path of red light through and out of the prism after point A. Here we have to draw the path of red light, and we have to remember that the y angle is greater than the critical angle of diamond. So, you can see that it is the angle y, and as the angle y is greater than critical angle, so the ray here will be totally reflected, and the reflection must be in this sense. So I draw the ray here. It is the path of ray inside the prism. We also have to draw the path out of the prism, and first of all we draw here the normal line. At this point I am trying to draw the normal line. And we know that it is not a denser medium that is outside. It's a air, simply it's a very lightly denser medium. So there will be no totally internal reflection, there is just refraction. So what will happen, this ray, there is an angle, let's suppose it is theta. So when this ray comes out of the prism and inside is a denser medium, outside is less denser medium. So what will happen to the path of ray? We know that when ray of light enters from denser to less denser medium, the ray will bend away from the normal. But in the case when it goes from less denser to denser medium, what will happen? It bends towards normal. In our case, ray of light is in a denser medium, and it is leaving the denser medium and comes out of the less denser medium. That's why it will bend away from this normal line. So I will draw a ray here. So you can see that this angle, if I suppose is at theta prime, this angle theta prime is greater than theta. It means that this ray bends away from normal. We also have to mention the path of ray, that's why I am putting arrows here. So it is the complete diagram for the light that travels from air into prism and then from prism into air. Question number 8, part 1. Describe what is meant by an electric field. Here we have to define what is the electric field. We know that electric field is a region in which the electric charge experiences a force. So I write the region in which an electric charge experiences a force. Part 2. State what is meant by the direction of an electric field. So what is meant by direction of electric field? We know that the direction of electric field must be in the direction of force. So I write here direction of force on a positive charge. Part B. So here you can see a figure. Figure 8.1 shows a polystyrene ball covered with aluminium paint. So it is covered with the aluminium paint, and we know that aluminium is a conducting material. The polystyrene ball is suspended between two charged metal plates by an insulated thread. So you can see in the figure 8.1 that it is the positively charged plate while the other is negatively charged plate, and it's the ball that is made up of polystyrene, and there is a paint over it which is of aluminium, and it's the thread that is insulated thread. The ball oscillates between the two charged plates. Explain why the ball oscillates. So first I consider that this is a ball and there is the paint of aluminium. We know that aluminium is a conducting material. So it is positively charged. No, this ball has positive charge. And this plate also be positively charged. When this ball moves towards this positive plate, the ball is at that position. No, it is also positively charged, and we know that same charges repel each other. Same charges repel each other. So the positive charge will repel the positive charge, and that ball move towards the other plate that is negatively charged. It is the negatively charged plate. Here ball is positively charged plate. So once it touches the negatively charged plate, it's going to lose its charge. So the ball lost its charges because the negatively charged metal plate start giving its negative charge to the ball, and there must be everything neutral. So at one point it can have much more negative charge. It's talking about the ball that it has much more negative charge, due to which we can simply say that the overall ball is negatively charged. So this negatively charged ball starts moving towards the positively charged ball, and in this way it moves between these two sides. So it starts oscillation. So I write here we have to explain the reason. First I will write about when the ball moves towards the positively charged plate. Ball moves toward positively charged plate. And touches it. Since ball is made of conducting material, it becomes positively charged. Then it will be repelled by positive charge plate. And move towards the negatively charged plate. When it touches negative plate, it loses electron. It loses its charge. The negative charge ball is attracted back to the positive plate and this process repeats. Part C. There is a current of 0.29 ampere in the electric circuit. Calculate the time taken. Here we have to calculate time for a charge of 15 coulomb to flow through the electric circuit. Here we have to calculate the time, and we know that current is defined as the rate of flow of charges. Here we have to calculate time. T is equal to Q over I. Charges are given, that is 15 coulomb, and current is 0.29. So by dividing we get 52 seconds. So time must be 52 seconds. Question number 9. Figure 9.1 shows a simple direct current DC electric motor. The coil rotates about the axis when there is a current in the coil. The coil is connected to the rest of the circuit by the brushes. Part A1. On figure 9.1, draw a pair of arrows to show which way the coil rotates. Explain the direction you have chosen. So in the figure 7.1, you can see that it's a coil, and The south pole and north pole, actually it's a magnet, and it's the axis in which coil rotates. And these are carbon brushes on both of sides, and it is the power supply where we have to supply power to the circuit. So you can see in this diagram we have to show that in which direction the coil rotates. So first of all, you can see that one is the positive terminal while other is the negative terminal, and we know that current flows from positive to negative terminal of battery, and that's why the current, we know that current flows from positive to negative terminal of battery. Here current flow in this direction, on this side it coming back. So the current here flow from positive to negative terminal of a battery. And now we consider the half section of this coil, and I draw a line here that is mentioned here, the axis of it. So it is the left side and it is right side. Here I have to use the Fleming left hand rule. And what this rule says, according to this rule, if I consider my left hand rule and its forefinger, middle finger and thumb, I set them in such a way that they all are perpendicular to each other. Then my forefinger represents the direction of field, and if the middle finger represents the direction of current, then my thumb represents the direction of force or the direction of motion. So you can see in the figure that current is flowing on the left hand side, current is flowing in upward direction, and the magnetic field is from north to south pole. It is the direction of magnetic field. So if I draw here that it is the magnetic field B and current is flowing in upward direction. So I apply Fleming left hand rule on this and see that my middle finger represents the direction of current, it's upward, and forefinger will be horizontal in the direction of magnetic field. Then my thumb will be in the downward direction, means that force is acting in downward direction here. It is the direction of force. Now if I apply this rule on the right hand side, you can see here that the current is flowing in downward direction. It is the direction of current. And magnetic field again in the same from north to south pole. And if I draw the diagram, it is the direction of current and it's the direction of magnetic field. So I can easily say that the force will be in upward direction. Here everything is same, I just change the direction of current. First of all it is upward, but in right side it is downward. So here the force will act in the upward direction. It is the direction of force. So you can see that the coil move in this direction. It will be moved just like this. Because in this side force is upward and on the left side force is acting downward. So there will be anti-clockwise rotation. Means that this moves in this sense. And I have to mention here, then the coil just move in the anti-clockwise direction. So it is the direction in which the coil moves. So in the part 1, On a figure 9.1, draw a pair of arrows to show which way the coil rotates. Here we have to show the direction in which the coil rotates. Also explain in the direction you have chosen. So I have also explained it. So I write here, current travels from positive to negative. Current travels from positive to negative terminal. And the force on left side will be the force on left side will be in downward direction, while on right side is upward direction, is in. That's why the coil rotates anti-clockwise. So moving towards the other part of this question. Part 2, on figure 9.1, draw the arrow to show the direction in which the electron flow through the circuit. Here we have to show the direction of electron, the direction in which the electron moves. So it also we have to shown on the graph, on this figure. So first I remove here some things. So we know that the current flows from positive to negative terminal of battery. It's a supply, and the current flows from positive to negative terminal. But in the case of flow of electron, we know that electrons are negatively charged and they must be repelled from the negative terminal. So the current or the electron flows in the direction opposite to the current. So I draw the arrows here. I'm changing the color. It's the direction for flow of electrons. They move in the opposite direction of the current because they are negatively charged and they must repel from the negative terminal of the supply. So we have mentioned the direction. In the third part, explain why the electron flow in the direction you have chosen in part A2. So here we have to explain the reason that why the electron flow in the opposite direction, because electrons are negative. And are repelled by negative terminal of supply. That's why they move in the opposite direction. Next part. Okay, part B. State any difference Each of the following changes makes to the rotation of the coil in figure 9.1. Part 1. Changing the polarity of the power supply to that shown in figure 9.2. In the first figure, we are shown here it is positive. It is positive while it's negative. But in this figure, it is shown that it is negative and it is positive, that we just change the polarity of that supply. And we know that the current flow from positive to negative terminal, in this case it flow in this direction, and it is totally opposite to the direction of current in the figure 9.1. So when the current is in opposite direction, then the forces will be inverted. First of all, force on the left side is in downward direction, but here it will be in upward direction, and the force here will be in downward direction because the magnetic field again is in this direction. So the coil here moves clockwise, not anti-clockwise. So I write here, I also have to show the arrows, the direction in which moves, so it will be the direction of flow of current. And in the next part 2, I also have to explain this reason. I write here changing polarity. The current flow in the opposite direction and the rotation will be in opposite direction. First of all, rotation is anti-clockwise. Here rotation will be clockwise. So I write rotates in opposite direction. So second part is changing the coil to a new coil shown in figure 3.1. So here you can see that it's a new coil, and the difference between the original coil and new coil is that in the original coil there is only one loop, while in the new coil there are two loops. And when we increase the number of loops, the coil will turn very faster. It moves at very fast rate. So I write here that the coil turns faster. Part 3, using a stronger magnetic field. So when I use a stronger magnetic field, again the coil turns very fast and it moves at very high speed. So I write again turns faster. Question number 10, Part A. A radioactive nucleus of carbon decays to a nucleus of nitrogen by emitting a particle. Complete the nuclide equation and state the name of particle. Here we have to tell the name of this particle X and also have to complete this equation. So first of all, we know that for balancing chemical equation, the number of protons, neutrons and electrons on both sides must be equal. It means that the atomic number and atomic mass on both sides of the arrow must be equal. So first of all, we check for left hand side and then for right hand side. Atomic number for carbon is 6, while here atomic number is given as 7. So to make these both equal, we subtract -1 here so that it becomes 6. It means that the atomic number of X is -1. And now we check the mass number. The carbon has mass number 14 and nitrogen also have 14. It means that the mass number of X element is 0. So I write here 0. We also have to identify the name of this particle, and it's a beta particle. Part B. A radiation detector in a laboratory records a reading of 10 counts per minute. There are no radioactive samples in the laboratory. Explain why the radiation detector records the reading and suggest a possible source. Here in the laboratory there is no radioactive sample that emits the radiation, but still detector records 10 counts per second. We have to explain the reason for that. First of all, it is due to the background radiation. Background radiation may be obtained from rocks, grounds, buildings, food, air, sun. So I write here explanation is that it is due to the background radiation, and these radiation exist even there is no radioactive source present. Sources are rocks, ground, buildings, food, air, etc. Part 2. Carbon-14 has a half-life of 5700 years. There are atoms of carbon-14 in all living organisms. An archaeologist digs up some ancient wood in the same laboratory as in B Part 1. A sample of this ancient wood gives a reading of 20 counts per minute. An equivalent sample of living wood gives a reading of 80 counts per minute. It is suggested that the age of the ancient sample is 11,400 years. Do a calculation to check whether this suggestion is correct. So first of all, you can see from here the counts are 10 counts per minute. But actually in the part 2, the counts are 20 counts per minute and 80 counts per minute. So we simply do calculation. We just minus these. I will write here as 20 minus 10. This is 20 counts and before it's 10 counts. So I subtract them. It comes to be 10 counts per minute. Also 80 minus 10 is equal to 70 counts per minute. So using these numbers, its half-life is 5700 years and the age of the ancient sample is 11,400 years. So we roughly say that the half-lives are 2 because when we multiply 5700 by 2, we get 11,400. So there are two half-lives. Next, since the counts are 10 and 70, we also have to check the half-life using these numbers. First of all, I check for 70 counts per minute. In the first half-life, half of this will decay and remaining will be 35. It is the first half-life. And again in the second half-life, it remains 17.5. Because this number 17.5 is greater than 10, that's why there is also another half-life. So it decays and gives 8.725 counts per minute. So there are 3 half-life involved, and this count per minute is less as compared to 10 counts per minute. So we can guess that the half-life lies between 2 and 3, because there are 10 counts per minute and here it's 8.72. So the half-life might lie between 2 and 3. So I write here 2 is less than x, it is less than 3. So our assumption about that half-life is 2, or it might be between 1 and 2, that we assume here, and its age is 11,400 years. It's a wrong assumption. So we can simply say that the age of ancient sample must be greater than 11,400 years, and half-life must lies between 2 and 3. Or we can simply say that the half-life is nearly 3, because 10 is very close to 8.72 as compared to 17.5. So our assumption is wrong.